colinear point to D?
F.
Yep. So F or D would, or F or E would, either one of those would have worked, right? So that was pretty simple. What about the next one? What equation can I set up here?
You could do X, like, no, you go with the parentheses, you're gonna do X plus 5 and then plus 21 and then equals 4X plus 11.
Nice. So then we combine our stuff and we get X plus 26 equals 4X plus 11. And then do you subtract the X or the 4X, just out of curiosity? Or does it matter? Putting my algebra teacher hat on for a second. I always subtract the smaller variable. You don't have to do that, but I'm kind of like allergic to negative numbers. So if you subtract the smaller variable and bring everything down, I know it bugs some people to have the variable on the left side, but then it's positive, and I make fewer mistakes when I have positive numbers. So that's why I do it this way. So if I move the X to the right, I'll move the numbers to the left. The 11s cross out. You bring down 3X, and 26 minus 11 is 15. So X equals 5. And then how do I find CA? So CA is this part. How do I find CA? Absolutely. I couldn't have said it better. So you got to plug in the answer you got with a variable, and 5 plus 5 is 10. So you got to make sure you're answering the question being asked. You guys are getting pretty good at that, those who did it. And then the next one, same thing, right? Is it asking me for X? So how would I find X here? What do I have to do to all of those pieces? Do I have to add them up? A lot of people miss that 1 right there. So you need to do 2x minus 6 plus 1 plus x minus 4. I don't know why our eyes skip over that 1, but a lot of people, that's like the common mistake. And then you combine all your like terms. So if I have 2x and I have 1x, that's 3x. And then minus 6 and minus 4 is minus 10. Plus 1, so that's minus 9 equals 18. Subtract, oh, not subtract, add your 9 to both sides. So 3x equals 27 and x equals 9. I'm going to erase some of this. So I don't always go over the homework, but I felt like we left yesterday with a lot of stress and anxiety, so that's why I'm going over it today. What's our formula for midpoint? Anybody remember? Yep. Uh-huh. Exactly. Perfect. And you're finding an ordered pair, right? So you need the parentheses and the comma in between. So we're going to do x plus x. We got to make sure we grab our x's. So I'm going to grab 5 and 11. So 5 plus 11 divided by 2, that's going to be my x variable. And then I'm going to grab my y's, 3 and 17. So 3 plus 17 divided by 2. Make sure you do the right order of operations, right? So I got to add my 5 and my 11 to get 16. 16 divided by 2 is 8. And then 3 plus 17 is going to be 20, and 20 divided by 2 is 10. Right? What about question 5? What can I label?
A, B, and 4, 5, 10.
All right. And what else can I label?
B, C, 2,
Awesome. So what equation can I write? How are those two things related, and how do I know? I know, such hard questions for 7:30 in the morning. There's a word in the sentence that helps us out. What word in the sentence is also important? Midpoint. What does midpoint tell us? The midpoint of my thumb is that knuckle right there, or the midpoint of my paper is halfway across, or I fold a sticky note in half and I get the midpoint. What's midpoint tell us? How are A, B, and B, C related? B is the middle for sure. So if A and C are the endpoints and B is the midpoint, then the segment to the left and the segment to the right are they equal? They should be. So anytime you have the word midpoint and it gives you two segments, one on either side, or two angles, we'll get to that next week, one on either side of a bisector, then those two things are equal. So my equation here is 4 minus 5x equals 2x plus 25. And I know up above, I said I always move the smallest variable. In this case, the smallest variable is a negative. So this -5 is my smaller variable because -5 is smaller than 2. So I'm going to add 5x to both sides. Again, I know this is going to bother some people because some algebra teachers tell you to do this differently. So whatever way works for you, this is just the way I do it. If I move my variables to the right, I've got to move my numbers to the left. So try as I may to get rid of negative numbers, it's not going to work. I've got 7x equals -21. So x equals -3. Now in geometry, most of the time we don't like negative numbers because we talk about real world, right? So in geometry, I've got real stuff. I can't have a -3-inch desk. It's not going to work. However, you can get negative variables as long as when you plug them back in, you get positive line segments. So if I'm looking for AB, I got to plug this -3, 4 minus 5 times -3. I've got to multiply this first, right, to get a positive 15. So 4 plus 15 is 19, and that's my final answer. So this question is super tricky for a lot of reasons. Number one, you got to know midpoint means the two segments are equal. Number two, you got to solve that crazy equation with variables on both sides. And number three, you got to plug in that negative and get all the integer stuff right. So a lot of ways to get this problem wrong. A lot of little tiny mistakes you've got to worry about. Okay. Questions on that? Could you go back and do it yourself and get all 5 right? I hope so. Let's look at the next one. Let's look at the quiz. I'm not going to do all the questions on the quiz, but I will let you guys tell me which 3 questions you want to talk about. So we can, absolutely. If I can get there. All right. So we can find the midpoint, right? That's the first question. Make sure you do that x plus x divided by 2, comma, y plus y divided by 2. That's your formula. Number 2, probably the same thing. What is the midpoint of AC? So here, make sure you're finding the midpoint of the right line. Same formula. Number 3, if xz is 50, so that's that whole distance, then what is the length of YZ? That's my question mark. So what equation could I write? What are the two parts?
2a plus 8 equals 50.
Exactly. So we're going to do a plus 8 equals 50. You already combined those in your head, and a lot of people can do that. In geometry, you need to show as much work as you need to show in order to get the right answer. Okay, so I'm not the work police. 50 minus 8 is 42, and then a equals 21. The tempting answer here is this one. Why is that wrong?
Because 21 is not y.
Exactly. 21 is A, not YZ. So what's the final step I have to do?
You have to 21 plus 8.
21 plus 8. So the answer is actually 29. And geometry is full of tricky things like this. You really do, and I will say it all year long, you have to go back and reread the question before you hit submit to make sure you're answering the right question. You can do all this perfect work and get A equals 21, see 21 as an answer choice and choose it and get the answer wrong after having done everything correct. It is maddening, but that's what geometry is like. What other questions? That was a really good one to look at. We can do two more. Yeah. Do you have a different number 3 than me? 3m plus 5. Okay, that's my number 4. So 3m plus 5 and 4m minus 10. Is that the one we're looking at? Okay. So how are those two things related? You've got these little tick marks here. What do those tick marks mean? Anybody know? Those mean congruent. So AX and XB are both exactly the same. Those little tick marks are congruent. And then what word up in the problem gives you a clue as to what you're supposed to do? Midpoint. And how are those two sides related if X is the midpoint? Are they equal to each other? So the left side equals the right side because X is the midpoint. They're both exactly the same length. So I'm going to subtract 3m from both sides because I like getting rid of my smaller variables. If I move my variables to the right, I can move my numbers to the left. So I can do this all in one step because then my 10s cancel out. 4 minus 3 is m, and 5 plus 10 is 15. Did I do that right? Does anybody see any problem with that? So find the value of m if x is the midpoint of AB. So is 15 not the right answer? Question mark? You're welcome. So we can do one more. Which one more do we want to do? Vocabulary should be pretty easy, hopefully. Do we need to do an endpoint or a midpoint? That's what we were talking about yesterday. Let's do either 6 or 7. Do we want to do 6 or 7? Because they're both kind of the same.
Try to look.
Gotcha. Good. So question 6, if the end point, so this is an end point, and the midpoint, this is a midpoint, what is the other endpoint, right? And then here we have an endpoint, and we have a midpoint, and then we have the other endpoint. So both of these two problems are going to be done the exact same way. Do we do x plus x divided by 2 and y plus y divided by 2? Or do we make a table and we do an endpoint, a midpoint, and then the other endpoint? Which way do we solve those? Choice A, or choice 1, or choice 2?
I've been doing it choice 1.
You've been doing it choice 1? So if you're given 2 endpoints and you want to find a midpoint, then you do it this way. If you have the 2 endpoints and you want the midpoint, you find the average between them. If you have an end and a middle, you want to put it in the table. So if I put my end here, -3, -5, and -1, 0, you want to find the pattern. So how do I go from -5 to 0 on a number line? Do I have to add or subtract? And we add 5, and then we want to follow that pattern, add 5 more. So this y value is going to be 5. I'm going from -5 to 0 to +5. And then here I'm going -3 to -1. So that's +2 on the number line. So I want to follow that pattern and do +2. -1 plus 2 is 1. I'm going -3 to -1 to 1. So my ordered pair is going to be right 1 up 5. And then it'd be the same for this one, for the number 6, right? You don't want to do this way because you have an endpoint and you have a midpoint. So you want to make the table. Does that help a little bit from people who were struggling yesterday with the quiz? Hopefully.
Yes.
Okay, good. Make sure you go back and do that. Has everybody been able to get in and do the delta math? Because I'm worried that we're falling behind a little bit. Okay. I'm going to go back into the unit folder and go into day 4. Today's task is distance. Was everybody able to watch all those videos yesterday? Because the videos are super important to watch at night before you come to class. So if you're not sure where the videos are, they're in your geometry notebook, which is always at the top of the unit folder. And I think it was 12, 13, and 14. So distance, we have vertical distance and horizontal distance and then diagonal distance. And there was a video right there. And then we've got Pythagorean theorem as a workaround. I personally like the Pythagorean theorem because I'm a graphic person, not an algebra person, but you kind of have to know yourself, right? If you like algebra and you like solving the equations, you're going to like the distance formula. And then we had some practice here with the distance formula. Are we all on the same page? Hopefully, thumbs up.
Yes.
Good. So I'm going to open this bigger so that we can all see it a little bit better. How would you plot this? If Don lives 3 blocks east and 5 blocks north, where would you put his dot? Like, where would he live? How would you do that? If I start at 0 and I go east, which direction do I go?
Right.
Right. So I'm going to go right 3. 1, 2, 3. And then if I go north 5 blocks, is that left, right, up, or down?
Up.
Up. So I'm going to go 1, 2, 3, 4, 5. Okay. So that's Don. And then if Frida lives 7 blocks east and 2 blocks north, I go 7 right. 1, 2, 3, 4, 5, 6, 7, and 2 north. 1, 2. That's Frida, right? So what we're going to try to do is figure out what that distance is. And the distance formula is going to help us, all right? So you might want a piece of paper if you don't already have one. If you have vertical and horizontal lines, it's really easy. You can just count just like we did. We can go 1, 2, 3, 4, 5. The distance between A and B is 5, right? What's the distance between M and N?
3.
3. You just count the jumps, right? Make sure you're not counting the lines. You got to count the jumps. Can I do the same thing here and just go 1, 2, 3, 4, 5, 6? Or does it not work when it's on the diagonal? It doesn't quite work on the diagonal because the diagonal is going to be longer. The hypotenuse of a triangle is always the longest side. So when you start going on diagonals, you need a slightly different way of doing things. And that's going to be our distance formula. I like to think of distance formula as a face. So if you have something to write with, what I want you to do right now is write with me. So if I think of distance formula, oops, I lost my pen. Distance formula as a face, right? The radical is my face. That's like this part of my face. We've got 2 eyes. That's the parentheses, right? Is it starting to look a little bit like a face? Then I've got a nose. That's a plus sign. It's my cute little nose. We're in math class and it's 7:30 in the morning, so we're all tempted to close our eyes because it'd be nice to go to sleep, right? And then I like details. I like pretty things, so we're going to put some eyelashes right there, right? So just to do it one more time, we've got a face, we've got 2 eyes, we've got a nose, we're sleepy in early morning math class, those are our eyes, and then I've got my eyelashes. And just like the midpoint formula, we're going to do X and X and Y and Y. Okay, so that's one way to remember the distance formula. This formula is not on your formula sheet for the SOL, and we are planning on doing SOLs, I think, round about January 15th. I don't know exactly, but this formula is not on there, so you do need to memorize it. How would we substitute our numbers here? What goes in my face? So I'm going to make my face and make my eyes, my nose. And then what goes in it? What's my...
We put like 9 in the first one.
Yep. Positive 2 or negative 2?
The positive.
The positive 2. Perfect. And then we're going to come over here. Those are my X's. So then I got to put in my Y's. Negative 2. And this is what I do. Instead of doing negative 9, I make that plus sign. Like I make my negative vertical. So instead of writing minus negative 9, I write minus negative 9, turns it into a plus. Does that make sense to everybody? Kind of, sort of, maybe? Because 2 negatives come together to form a super plus is what I used to call it when I taught middle school, right? So then 9 minus 2 is, now we just solved it with the order of operations. 9 minus 2 is 7. And negative 2 plus 9 is another 7. And then 7 squared and 7 squared, that's 49 plus 49. And square root of 98. You can leave it just like that, or you can turn it into a decimal. It just kind of depends on what you want to do. Everybody cool with that? Sweet. Let's try the next one. What if, you tell me if I can do this or not. What if I do this? Because I told you I was allergic to negatives, right? So I've got a minus, I've got a cute little nose, and then 5 minus 1. Am I allowed to do that? Can I start with the 6 instead of the 3? We can do that. It's tempting to say no because a lot of teachers do this. They do X1, Y1, X2, Y2, and they force you to start with that 3. If it is easier to start with the second one, you can do that. You just have to be consistent. If the 6 comes first, then the 5 has to come first. If the 3 comes second, then the 3 has to come second. And the 1 has to come second. Okay, so you can use whichever pairs x1 and x2 as long as you're consistent. That's what this little bubble means here. So if we do 6 minus 3, that's 3, and 3 squared is 9, and then 5 minus 1 is 4, and 4 squared is 16. That's the square root of 25, which equals 5, right? This one I want you to do on your own, and so I'm going to give you a couple minutes, and then you tell me what you got. I'll give you about another 30 seconds, I think. So what x did you put first? The -6 or the 5?
I put the 5 first.
Cool. So if the 5 goes first in the first set of parentheses, then the -1 has to go first in the second set of parentheses, right? We just got to be consistent. So if the 5 goes first, then we do a -6. And again, we've already got a minus, so I'm going to make my -6 into a plus and -4, right? There's Sev. So now we're going to do our math. 5 plus 6 is 11, and 11 squared is 121. And -1 minus 4 is -5, right? So -5 squared. What's -5 squared? Is it positive 25 or -25?
Positive.
Why?
Because a negative times a negative is a positive.
A negative times a negative is a positive. If you put into a calculator -5 squared, you're going to get -25. What you need to do is put in parentheses -5 squared. So when I was teaching middle school again, I used to tell my students, if you have a negative number, it's very sad. You need to give it a hug. Anytime you put a negative number into the calculator, I want you to put parentheses around it. It's like giving that negative number a hug and trying to make it positive. Okay? Make sure you do this. If you don't, you're going to get silly mistakes, because we all know that a negative times a negative is a positive, but sometimes we put it in the calculator and we're like, well, the calculator said, right? Well, the calculator is only as smart as we programmers are, and sometimes we programmers make crazy mistakes. So final answer, square root of 141. Again, you can take that down to a decimal. It just depends on what it's being asked for, right? Am I going too fast? Are we okay? Okay. Do we need to do another one?
I don't.
Yeah.
Yeah? Okay, let's do another one. So take a minute, do this one on your own. Remember, distance formula is our face, eyes, plus sign for a nose, sleepy math eyes, but eyelashes because we're all cute. And then you got to decide where you want to start. Which X do you want to start with and which Y do you want to start with? So what number goes in that first position? 0, -6, or 8? Eight, we can definitely put 8 in there. So if I start with 8, then my 0 has to come first in the second box. And then I need to put my 0, which is my X from over here, and my -6. So again, I'm just doing minus a negative. Minus -6 turns into a minus -6, a plus 6. So 8 squared is 64, and 6 squared is 36, and 64 and 36 is 100. 100 is a perfect square, so that's easy peasy. Boom. Awesome. All right, now we're going to change it up a little bit. If I give you points on a graph, you can do the exact same thing. So if you like algebra, you can go look at this and you can say this is 2 and this is 8 and this is 7, 3. And you can do the distance formula, right? 2 minus 7 squared plus 8 minus 3 squared. Or we could flip it around and do 7 minus 2 squared plus 3 minus 8 squared. It's not going to matter which way you do it. Sometimes, though, it's easier to do Pythagorean theorem. So if you make a horizontal line across for my B, right? Let me change my color so I match. So this B right here is a horizontal piece. So I go 1, 2, 3, 4, 5. We got to make sure we have a right angle here. So this has to be a right angle. So this bottom piece, the horizontal part, is 5. And then the up and down part, the vertical part, is 1, 2, 3, 4, 5, right? So we've got 5 and 5. 5 squared for the vertical piece. And 5 squared for the horizontal piece is going to make 50 equals c squared. And then you take your square root, and your distance is just square root of 50. Right? Down here, we're going to end up with the same thing. 2 minus 7 is -5. -5 squared. And 8 minus 3 is 5. So 5 squared, and when we take the square root of all of that, we're also going to get square root of 50. Poor Tania is just being kicked out all over the place. So I know I went through that really fast, right? Let's look at another example and see if we can make it make sense, right? So I have 2 points here. I don't have any lines. I want to make that horizontal B part. That horizontal B part. So I'm going to go to the right from this point until it's directly under the next one, because I need that to be a right angle. That's 1, 2, 3, 4, 5, 6, 7. Is everybody okay with that? Then we're going to go over here and we're going to start at that same point, or where we ended, and go up 1, 2, 3, 4. So we can go 1, 2, 3, 4. And the vertical part, that A part, is 4. So our equation now for A squared plus B squared equals C squared is 4 squared plus 7 squared equals C squared. Pythagorean theorem. Everybody remember vaguely Pythagorean theorem from middle school? Hopefully. And then 4 squared is 16, and 7 squared is 49, and we've got c squared, and then 16 plus 9 is 65. It is early, so if I make some kind of crazy mistake, you got to call me out on it. So c equals the square root of 65. Some people find this easier because you don't have to find the points. In order to do the distance formula, you would have to say this lower point is 2, 2, and this upper point is 9, 6. So you'd have to find your points and then plug them in. So we would do 9 minus 2 squared plus 6 minus 2 squared, and we should get 4 and 7. So 9 minus 2 is 7, so that's 7 squared, and 6 minus 2 is 4, that's 4 squared, and we take the square root, and we should end up with exactly the same answer. Okay, so again, I know I did that quickly. We're going to try this one, and I'm not going to talk, you're going to talk. You tell me what I need to do. So what's the first step?
The horizontal thing.
The horizontal thing. And how long is my horizontal line?
Until it's directly under the other point.
Okay. And how long is that?
2.
It does look like 2. And then what's the second step?
Draw the next one, which is vertical.
Yep. So I draw that. And that's how long?
That's it. 9.
Beautiful. So what's my equation for Pythagorean theorem? Because I'm trying to find that diagonal distance. I'm trying to do the shortcut.
First you gotta find the point. So,
Do you have to find the points if I know those two numbers? What's my A number? What can I substitute for A? It's red.
9, right?
Yeah. So we're going to do 9 squared. And what's the B number? 2. And that's going to equal the C. So over here, that hypotenuse is going to be my C. So then I just square them. 9 squared is 81, and 2 squared is 4. That's all calculator work, right? So then 85 equals C squared. And then what's the last step? How do I get rid of that square right there? Take the square root. Beautiful. So C is going to equal the square root of 85. Right? Now, again, if you don't like this method on the graph, you can definitely find your 2 points and plug them into the distance formula. We've already practiced that, so I don't really want to spend a lot of time practicing that and keep you, forever and a day. Let's do 2 more of these and see if we can figure them out. So, I feel like this is the same one. Yeah, I think that's exactly the same one. I think I need to delete that slide. What about here? Slide 11. If I'm going to use Pythagorean theorem, what do I need to do first? Find the horizontal. Now this one is really long, so it might play tricks with your eyeballs. And that's why some people don't like this method. So sometimes what I do is if I'm not quite sure, I draw it a little bit too long, and then I make the other one until they meet, right? So how long is my red line? Is it 4? 1, 2, 3, 4, 5. I think it is 5. It's hard to see, so that's why we got to check each other. And then what about the horizontal one? This one's going to be even harder to count. Nice. So then what's my equation? If it's a squared plus b squared equals c squared, I've got a red a and a green b. Beautiful. And 5 squared is 25, and 12 squared is 144. Hopefully your algebra teachers made you memorize those. And now my brain is not working. Is that 169? Sweet. And the final step to get rid of that square is take that square root. Nice. And the square root of 169, that is a perfect square. This is what we call a Pythagorean triple. It's a special right triangle that has 3 whole numbers. That doesn't happen very often, right? How are we feeling about this? Better than we felt about midpoint? I hope. There are a lot of questions yesterday.
Yes.
Okay, good. Let's see, we've got 2 more slides. Let's go straight to the last one. See what that one looks like. So try this one on your own. Find the height of the triangle, find the width of the triangle, or find the ordered pairs and put them in the equation, whichever one you think is going to be your favorite method. Did everybody get square root of 45? Hopefully. Good. There were some weird negatives if you use the distance formula. And I don't know if anybody was watching me on the board. I plotted this point as -2 instead of -3. So I had to go back and make a correction because I had to change the -3 and then change the 6 with all kinds of stuff, right? So